Hello world, Max here, and today I'll talk about the Factorial Challenge. I decided to pick this challenge as my first video to this channel because although it's a simple and common challenge, it also allows us to explore some concepts of programming and also for the languages we are working with. In this case, I will use Ruby to implement that because that's the language I'm most comfortable with. So let's dive into the problem. Well, in mathematics, the factorial of a non-negative integer n, denoted by n exclamation mark, is defined by the formula n factorial is equal to n times n minus 1 times n minus 2, blah, 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 times 2 times 1, which can also be denoted as n times n minus 1 factorial, the factorial of n minus 1. So by definition, the factorial of 0 is 1. So that's our base case. And here a few examples. So 5 factorial is equal 5 times 4 times 3 times 2 times 1, which equals 120. And 4 factorial equals 4 times 3 times 2 times 1, which equals 24. And 3 factorial is equal to 3 times 2 times 1, which equals 6. So we can check that 5 factorial equals 5 times the factorial of 4, which we can see here. That is part is equals this one, so that helps us with that. So yeah, let's try to implement that solution. You can see that if I just run the code, we have every result as new because we didn't implement anything. So let's just start. So let's first think of the base cases, which is the factorial of 0. So we must return 1 if it is 0 or if n it's 1. So I guess this will go. We have the base case, so let's just use another condition clause to guarantee that our n is always positive. So let's return new if n lower than 0. So yeah, so let's dive into our solution. So let's do a loop. Let's get n down to 1. Let's call the variable ni. So I'll take the number n and then I'll iterate until I get to 1. So first time I enter the loop, the value of I would be the value of n. Then each time it will decrease by 1 until we get to 1. That's what we're doing here. So if we look at our example, 5. First time we iterate the loop, the value of I will be 5. Then next time the value would be 4, then 3, then 2 until we get to 1. So that's what this loop is doing. So first time we have factorial. Let's store this on another variable. I'll start it as 1 because every number multiplied by 1 is itself, so we can start here with that. So we have a factorial. We need to multiply it for the value it already has. So first time, let's see, for example, let's try this with 4. First time we enter, we have 4. 4 times 1 is 4. Next time, the value of I would be 3, and the effect is 4. So we multiply 4 times 3, then so on, until we get to 1. So for factorial, we expect to have 24. So okay. And at the end, we need to return this. Let's run and check if everything is okay. We have 2, 6, 24, 120, 720, and then 1 and 1. I decided to put the base case at the end. So it seems that everything is working. Yeah, but there's another way to solve this, and that's one I really like because it uses recursion, and I'll try to implement that here right now. So let's think of this. The factorial of n is equals n times factorial of n minus 1. So thinking of that, we already have our base cases in our solution, but we can now try to use this recursion, this recursive solution. So we know that the factorial of n is equals n times factorial of n minus 1. And we believe that this could give us the right solutions. So let's try to run this again. And here we go. 2, 6, 24, 120, 720, 1 and 1. Let's clear this. Okay, so we now implemented our solution using a recursive way. Yeah, recursive solution is fine. And I still have one other option to show you. So I'll try to implement this using injection. So inject is a feature of the Ruby language. I know that a lot of other languages implement this. For instance, JavaScript also has an inject. And in Ruby, inject is also analyzed for reduce. You can use both work the same way. They're just analyzed for the same thing. And let's try to check if this works. Yeah, we have the same results. So this is it. I just showed you three ways to resolve the factorial challenge. I know there's a lot more ways to do that. This is the three I like the most. And if you have another one, just leave in the comments and let's chat about that. I hope you enjoyed. See you then. Bye bye.